Hello and welcome to Advanced Engineering Mathematics. My name is Nathaniel Posesorsky, tutor at Nimbus Tutoring, and today we are going to be looking at Laplace transforms, or the definition to be exact. So what is a Laplace transform? Well, we know that from Calculus 1 and Calculus 2 that if we take a function and we find its derivative, we get a different function. And then if we do the integral, we get back our original function. Well, the Laplace is a little different. We are going to now take our function f of t, and if we do the Laplace of f of t, we get a completely different function called f of s. And then if we want to get back our f of t, we must do the inverse. So you're probably wondering, what is the Laplace and what is the inverse? Well, the Laplace states that the Laplace of f of t is equal to the integral from 0 to infinity of e to the minus st times our f of t dt. And that is simply f of s. And then to get back our f of t, we do the inverse. So the L to the minus 1 of our f of s, and that gives us back the Laplace to the minus 1 of our integral from 0 to infinity e to the minus st times ft times dt, which is simply f of t. So now this might sound very theoretical, so why don't we look at an example to better understand? So over here they tell us, find the Laplace if f of t is equal to 1. Now, a great thing to do before doing any example is to write down the theory that we know. So over here, we are going to write down what we just said. The Laplace of f of t is equal to the integral from 0 to infinity of e to the minus st times our function f of t dt. And that's equal to f of s. So step 1 for finding the Laplace of f of t if it's equal to 1 is to plug f of t into our theory. So the Laplace of f of t is equal to the Laplace of 1, which is the integral from 0 to infinity times e to the minus st times our function 1 dt. So we just finished step 1. Now step 2 is going to be to find a way to solve the integral. So we are going to do the derivative with respect to t of e to the minus st. So if we do di e to the minus st over di t, this is the derivative with respect to t, we get minus s times e to the minus st dt. Now the reason we did this right here is because now we could isolate the e to the minus st dt over here. And we get di e to the minus st over di t times minus 1 over s. And that's equal to e to the minus st dt. Notice how what we found over here is the same as what we have over here in step 1. So now the final answer in step 2 is going to be equal to what we were trying to integrate in step 1. So step 3 is going to be to plug in what we found in step 2 into step 1. So the Laplace of 1 is equal to the integral from 0 to infinity of e to the minus st dt. And now we plug in what we found over here for the e to the minus st dt. And we get the integral from 0 to infinity of di e to the minus st over di t times minus 1 over s. Now we know that minus 1 over s is a constant, so we could take it out of the integral. And we get the integral of 0 to infinity of di e to the minus st over di t. And we also know that the integral of a derivative simply gives us the function that we're trying to derivate. So we get minus 1 over s times e to the minus st, all of that evaluated from 0 to infinity. Now if we plug in 0 to infinity into our t, we get minus 1 over s times 0 minus 1, and it gives us a final answer of 1 over s. So this means that the Laplace of 1 is equal to 1 over s. Now if they asked us to find the Laplace of 4, what would we do? Well, we know that the Laplace of 1 is 1 over s, so using that logic, the Laplace of 4 is 4 over s. And so, in truth, the Laplace of any constant is that same constant number over s. And we could see it over here as the first rule in the table of Laplace transforms. This table is going to prove itself very useful when you're going to be asked to solve more complex Laplace transformations. So I hope this was helpful in better understanding Laplace transforms. If so, please leave a like and subscribe. My name is Nathaniel Posesorsky, tutor at Nimbus Tutoring, and I'll see you in the next video. Thank you.